In this video, we'll look at RAII, a cool C++ acronym and a useful design pattern for avoiding resource leaks. RAII stands for Resource Allocation is Initialization. We will see what this means and how to use the pattern while creating a very cool cat that freezes resources automatically when it dies. Suppose that you have a block of code within curly braces. Curly braces define a scope. Any variables or objects created inside a scope will not be accessible outside. For example, we could create a cat object over here. The cat gets constructed. Then we can have some code that uses the cat. Finally, when we leave the scope, the lifetime of the object comes to an end. The cat destructor gets called and it gets destroyed. Unfortunate for the cat. Now, if the cat has allocated some resources, either in the constructor or in member functions, and these resources were not freed, then we have a leak when we leave the scope and come over here. RAII is a programming pattern that helps with this problem. Because destructors are called automatically when leaving the scope, we can actually use that to our advantage and free the resources there right in the destructor. The key idea is to tie the holding of resources to the lifetime of the object. You allocate the resources when constructing objects. You deallocate resources when destroying objects. Destruction happens automatically when the lifetime ends. So when you leave the scope and come over here, you can be sure that the resources were freed. Now, what about if an exception is thrown here inside the code that is using the cat? Will the destructor still get called? The good news is yes, the destructor will get called. When the exception is thrown, stack unwinding happens and the destructors get called in there. Which is great, we can still use the destructors for cleanup tasks. Let's do an example. So first let's make a main function. Then let's make another function foo. we're going to be making a cat class which showcases RAII. So this foo function constructs a cat object and then calls some member functions. So there is walk, sing, and jump. Sing, we're going to make that function throw an exception. Let's now call this foo function in main. The next thing now is to go ahead and implement this cat class. We're going to place it in its own header. So we include that header over here. Let's add a documentation comment. Let's call it RAII-cat. So it's a cat class that follows the RAII pattern. This cat allocates some resources. Like we said before, RAII is about managing the lifetime of resources and making sure that they are deallocated once they are no longer needed, once the object is destroyed. And what kind of resources are we talking about? So in general, it has to do with any action that once you do this action, you have to at some point undo this action. One example is you allocate memory. So you allocate a chunk of memory on the heap, let's say. At some point, you want to deallocate this memory so that it's not leaked and it's available for use at some other point in time. Another example is a lock. Locks can be useful for synchronizing concurrent processes. So for example, if you have two processes and they both need to access a shared resource, and they should not access this resource simultaneously, but only one at a time, then the lock can be very useful here. Another example where RAII can be helpful is you authenticate yourself, and then later on, for security reasons, once you're done with the task, you should de-authenticate yourself and not stay forever logged in. Our cat has plenty of resources that need to be taken care of. First, it has a lock. What does a cat need a lock for? Don't ask me. Maybe it has a secret food cabinet with all kinds of cat food, and once the cat dies, we don't want this food to be locked away forever. Let's see how we can use RAII to take care of this lock. This cat really loves to shop. It has a huge shopping list. And of course, this shopping list has to be stored somewhere and uses up some memory. The cat also has some data. It allocates some data, so let's make it have a data pointer. Finally, since the cat is a superstar singer, it needs a bank account so that it can store all the wealth that it has accumulated. For security, once the account has been logged into, it shouldn't stay in this logged in state forever, but once the cat is done using it, it should be logged out. The account should be logged out. A cat of many resources. Let's now go ahead and implement these classes. So let's make them empty for now, just for the example. So a log, data, and account. Let's also make some functions. So one function to get a log, to acquire a log, so to say. This returns a log object. And another function to release the log. So this takes a reference to the log, and in there it should release it. But we just leave it empty for this example. Then let's do the same thing for the account. We make a login function. It returns an account. And a log out function. This one takes the account and it logs out. It does some logic for logging out, which for this example we'll just leave it empty. Next, let's initialize the resources of the cat. I'll be using default member initializers for that. So for the log, I use the getLog function. Let's make a little change here. It would be better for this example if we use a vector instead of an array. The reason is that by default, the vector will allocate its elements on the heap. Whereas with an array, the elements might be allocated either on the stack or on the heap, depending on where the cat object is allocated. And let's initialize this vector with some shopping list. So some milk, because of course cats love milk. And also let's add in there some fish. And for the data, we're gonna allocate a data object on the heap with new. last but not least, we initialize the account with the login function, which should give us an account in the logged in state. And let's now include the headers that we need. So we need vector, we also need new. Let's also include IO stream because we're gonna be printing. We want to print a message in the constructor so that we can see when the cat is created. Let's now implement the destructor. So in order to use RAII, the destructor has to deallocate the resources. So let's go through them one by one. The first one is the lock. So this lock has to be released. So we're going to use the release lock function. Next, the shopping list. So this one is interesting because vector is a container. It's a class of its own. When the cat is destroyed, the destructors of all the members get called automatically. So this means the destructor of the vector class will get called. What will the destructor of vector do? It will basically destroy all of the elements. Vector actually follows the RAII pattern. This makes our life a bit easier because we don't have to worry about deallocating the resources held internally within vector. The vector itself takes care of that. Next, we have the data pointer. So that one we have to manage on our own. We have to use deletes. As for the bank account, we have to call logout in the destructor so that once the cat dies, the access to its account is somehow locked. Now let's implement the member functions. What member functions did we say we wanted for the cat? So it was walk, sing, and jump. Let's go ahead and create these. So for walk, we're gonna print out cat walking. Let's also implement sing, and there we're gonna print out cat singing. Finally, with jump, we'll print out cat jumping. As promised, we're gonna do something here a little interesting. We're gonna throw an exception in sing. So let's first include the header std except. Then let's go back to sing and throw a logic error. Let's actually comment this out for the start. Now, let's try running our code. Looks like the build has failed. There is something that we have to fix. I have made a typo. This is the wrong brackets. Let's fix that. And let's try again now. Perfect. So it's working as expected. First the cat is created, and then the cat, we call the member functions, cat walking, cat singing, cat jump. I'm gonna fix that shortly, jumping instead of jump. Then cat destroyed. Let's fix the jump, make it jumping. Now let's uncomment the throwing the exception and try again. Oops, so what happened? So cat was created, then cat walking, and then we called cat sing, and there an exception is thrown. And we were hoping to see cat destroyed as well, but that's not the case. Okay, so what went wrong? This is expected. The destructor was not called because the program crashed. The exception was thrown, but it was not caught anywhere. And then, therefore, the program crashed. What we need to do is to actually catch the exception. Let's go and do that next. So we're gonna have a try catch block. We try to call the foo function. And we catch the logic error. So a logic error because we have thrown a logic error. We are capturing the error by reference and not by value to prevent slicing, which might be a topic for another video. Now let's give this a quick run. Now it's working as expected. So the cat is created, then cat walking, and then while it tries to sing, an exception is thrown, and then the cat is destroyed despite the exception. And when we have caught the error, we print out that it was a singing failure. The destructor gets called when the lifetime of the object ends. The lifetime can end not only when leaving the scope, but also in the stack unwinding process, if an exception is thrown. With RAII, since we're using the destructor for cleanup tasks, we can make sure that there aren't any resources leaked. I hope you found this video helpful. Leave a comment if you have a question or a remark, and I'll see you in the next video.